What's up YouTube, this is Print Practical. Today we're going to be talking about 3D modeling threads for 3D printers. There's a ton of different variables that affect how well or how poorly threads work in a 3D model on your 3D printer. Things like the accuracy of your 3D printer, what material you're printing, what tolerances the model was designed with. I'm going to be showing you some tips on how to optimize the threads in your model for your 3D printer and material of your choice. I found that when 3D printing some larger threads like M20, M25, those prints seem to work totally fine without any type of adjustment on my printer. And I see the real need for this video for the smaller threads. I've recently made a gift card box which had 24 M6 screws, and those threads were quite fine. And it took me a few iterations to perfect the design to make the threads work really well. Okay, to start off simple, I made a simple block and I put two holes in it, one in the top, one in the side, and I made them M6 by 0.8 threads. I also made a screw with a fancy little knurled knob, and I made the threads for this M6 by 0.8. So we're going to print these out and then I'm going to try and screw them together without any modification. So here is our test A, which is just our base test. And we are going to try and screw this into the top side. I don't know if you can hear that. Oh, it is very tight. Oh, hopefully I can unscrew it. There we go. So I have two strategies that you can use to make 3D printed threads perform better. And you could do it to either the internal thread, the external thread of the screw, or you could do it to both, and it really just depends on your use case. So the first modification I'm going to do is I'm going to add more of a tolerance to the threads. Let me show you. So here's my original screw, and this is what I'm going to do. I'm going to use the push-pull tool. And first, I'm going to select the outermost part of the thread, and I'm going to offset that in the negative direction. So I'm going to offset that negative 0.15. And as you can see, it's pushing that peak inward towards the center of the screw. So I'm going to hit OK. And the next modification I'm going to do is I'm going to add a little bit of tolerance on each side of the thread. So I'm going to select the coil on both sides of the thread. And since I'm doing both sides, I'm going to half the tolerance. I'm going to do negative 0.075. So there you go, that added a little more tolerance to the threads. So let's go and do the same thing to the block. So here we have our block. So I'm going to use the press pull tool. And first I'm going to select that topmost face in the threads. And we're going to do a negative 0.15. And then I'm going to use the press pull tool again. And this gets a little harder to select, but I'm going to select both faces of the coils, and I'm going to do that on both sets of threads. There we go. And I'm going to do negative 0.075. Now both our block and our screw have a better tolerance for the threads. All right, the second tip that I have is adding a chamfer to the front edge of the screw and the front edge of the block. This makes it a little easier for you to get the threads started, and it just looks a lot better in the model as well. We're going to add the chamfer to our screw. Now I'm going to show you some incorrect ways of doing this, and then I'll show you the proper way of doing it. So we're going to hit chamfer, and as you can see, you can't select the whole front face because of the threads. So what you can do is you can rewind your timeline to go before you made the threads. Now we can use our chamfer tool to chamfer the top edge, and let's say 0.5. That looks good. So we're going to do that. And then we're going to fast forward our timeline. And now we have a nice chamfered edge. So in order to show why this chamfer is incorrect, I created a sketch in the middle of my screw, and I drew a few lines here to show why this chamfer causes an issue. So the first line I drew was completely horizontal, and it connects the peak of the thread on the left side to the edge of the screw on the right side. And as you can see, the width of that is 5.297. Now when I added this chamfer, it actually created a diameter that is larger than the rest of the screw. And if you were to 3D print this, you would see that you would not be able to get this screw to start threading into any hole, because the diameter of the edge of the chamfer at the bottom is 5.592, so it's a little too large, and you would just never be able to start it. Luckily, this is an easy correction. All you have to do is you have to select the chamfer feature, and you just need to drag it past the thread. And now, as you can see, the thread runs up through the chamfer. This gives you a nice chamfered edge without increasing the diameter of the screw. Now let's quickly add the chamfer for the block. So what we're going to do is we are going to do the chamfer tool, select these two edges, 0.5 millimeters. Now before I move the chamfer feature, let me just hammer back this point again. Look at this chamfer. It is causing a constriction here in the hole, and there's no way you would be able to get the screw started. So all we have to do, take the chamfer feature, slide it past the threads, and boom. Now we have a nice chamfer, but the threads come up into the chamfer. We're not constricting the diameter at all, and these will work great. Let's get the modified block and screw printed, and then we will try them with the original blocks to try all the different combinations and see what works best. So on the left side here, we have our original block. On the right side, we have our modified block. And just from looking at it, it's really hard to tell if there's really a difference between those two holes. But let's give it a try. So here is our original screw. As a reminder, let's try and screw this into A. And once again, very, very poorly. Now let's try it in our improved block. Works so nicely, and it is bottomed out. And I can crank on it, and it is working really nicely. Let's try this in the side. Having some trouble getting it started here. And it is a little tight. Now I have our improved screw. It's probably hard to see, but I have it marked. Let's go into the original block. Very nice engagement. And crank down on it. This is our modified block now, and it just pushes right in. So the added tolerance on both the block side and the screw side causes the screw to just fall right into the block without having to be threaded. The side of the original block. Ooh, easily just threaded right in. Got bottomed out. So in this experiment, it looks like the original block and the modified screw turned out to be the best combination for my printer using this white PLA and an M6 screw. So if you could do me a favor, subscribe to the channel and put a comment down below. Feel free to leave any type of suggestions on things you want me to make content on in the future. I gave you 2 different tips that you can use to make 3D printed threads work better. The most important one is adding a tolerance to the threads on either the screw or the hole or both. Depending on your use case, I highly recommend printing out a small test block like I did as an experiment in this video, but it could save you a lot of time before you go and print your massive prints. The second tip was to add a chamfer to the screw and to the hole. Now this is less important, it just makes it a little easier for your screw to start threading into the hole. And that's gonna wrap it up for this one. So thanks for watching, see you next time.